Welcome to the SARC seminar on nature-based solutions innovation. This session will focus on the nature-based function of intertidal salt marsh and mudflat. For this 10-minute session, we've prepared a few conventional PowerPoint slides, as well as video footage to keep things interesting.
Intertidal salt marsh and mudflat habitat consists of soft fine sediments such as clay and silt that are rich in benthic and halophytic fauna and flora. These areas can be defined as intertidal, being flooded and drained by salt water during tidal cycles. These areas are characterized by unique flora, including bacteria, diatoms, algae and halophytic flora such as Atlantic salt meadows. Salt marsh also supports up to 32 invertebrate species, including amphipods such as shrimps, isopods such as crabs, gastropods such as snails, and polychaeta such as ragworms. The area therefore attracts significant numbers of wading birds that feed on these benthic fauna and flora.
Salt marsh and mudflat habitats are known as Cinderella habitats, seemingly inactive but performing crucial ecosystem services. The ecosystem services provided are wide-ranging, but as part of this SARC seminar, we will focus on the relevant functions of coastal defense, ecology, and carbon sequestration. We do not wish to disregard the other services. It is merely a selection to fit into this time allocated. In relation to climate change, salt marsh is equally as important to forests and the barrier reef. As before mentioned, salt marsh is home to unique ecology that can tolerate not only the saline environment, but also the regular rhythm of the tides, flooding and ebbing. During the summer, temperatures can be extreme on these open expanses, drying out the surfaces, whilst during the winter, the surfaces can freeze when exposed to the elements. The extreme conditions have led to some unique flora, including several protected species.
One of the most relevant ecosystem services to SARC is the ability to attenuate wave energy and as such providing a low energy environment that reduces flood risk. Salt marsh can therefore act as a type of coastal defense and has done so for millions of years. This is supported by scientific data. For example, in 1996 and 1999, Muller and others showed that incident wave energy reduced by an average of 82% over Pioneer salt marsh on the North Norfolk coast, compared to only 29% energy reduction over a comparable width of fronting sandflat. Due to the energy attenuating character of the salt marsh environment, it has the ability to trap sediment. The rate that this sediment is trapped and subsequent increases in marsh elevation matches that of sea level rise, offering an adaptive solution to sea level rise in relation to coastal defense. This has been shown in a number of scientific studies. For example, vertical accretion rates on salt marshes in southeast England have been calculated in the order of 2 to 3 millimeters per year, which is sufficient to compensate for the estimated relative sea level rise of between 1.2 and 3.4 millimeters per year. Furthermore, salt marshes play an important role in the global carbon cycle, acting as a carbon sink. This carbon sequestration is achieved by sedimentation as well as the burial of organic matter, causing the soil carbon content to be notably high. Some of this organic matter is converted to methane. However, the regular inundation with salt water reduces the activity of methane-producing bacteria. Again, this crucial ecosystem service is further supported by scientific data. For example, McLeod and others in 2011 found that salt marsh habitat sequester carbon at a rate of around 55 times greater than tropical rainforests, locking up to 87 teragrams of carbon per year. This is also supported by Beaumont and others who in 2014 calculated that if the current combined coastal margin habitats are maintained, their carbon sequestration capacity over the period from 2000 to the year 2060 is valued in the region of £1 billion.
Salt marsh is a nature-based solution that has stood the test of time, and we're just discovering how important it is. Its function in the carbon cycle, ecology, and wave attenuation makes it an ideal candidate to consider. In the UK, 88% of estuaries are bounded by artificial defences. This means that salt marsh cannot develop up the shore or migrate inland during a process known as rollover. Coastal squeeze has caused salt marshes to shrink on an international level due to coastal development, anthropogenic influences, including sediment removal, and the construction of hard defences. Organisations are working on the management of salt marsh as part of efforts to adapt to a changing climate. By identifying pressures, active intervention through legislation, as well as restoration. We have experience of salt marsh restoration utilising dredged sediment to achieve the relevant elevation, period of indonation and exposure. The full zonation of these habitats should be considered as well as the hydrological regime before attempting salt marsh restoration. Creation of brushwood fences and polder-type structures allows for the protection of sensitive marsh and encourages natural deposition of sediment into the polders as long as sediment remains available. This is a long-term solution.
As a response to the 1953 flooding, pits and dikes were dug to obtain material to construct flood embankments. These borrow pits and borrow dikes are now part of the landscape and especially prevalent in Norfolk, Suffolk and Essex. They provide a useful opportunity to fill in and regenerate and restore the salt marsh that was once there. The fill of these pits, or lagoons as such, can be achieved with dredged sediment. Once filled to the correct level, pioneering salt marsh will quickly migrate into the pits to colonize it. Salt marsh can be restored by placing dredged material in sheltered areas at the right elevation. The dredged material, usually clays and silts, is required to have the right consistency, including moisture content and cohesiveness, to avoid it being washed away by the tides and currents. This is usually achieved by mechanical equipment, often track plant with buckets, placing sediment to form polder. All of these methods demonstrate the concept of using sediment as a resource rather than considering it a waste, to develop and regenerate a vital habitat which provides key ecosystem services such as flood defense and erosion mitigation.
We can conclude that it is important to consider salt marsh and mudflat into regional coastal defence policies and management strategies, including their vulnerability to coastal squeeze and limitation to function properly if bounded by hard defences. We hope that this session on nature-based solution was informative, and we look forward to discussing any questions during the question and answer session or via our contact details.